Discrete probability distribution and its applications are illustrated in this example. MRI technician is servicing MRI machines at a hospital. Depending on the type of malfunction, a service call or repair can take 1, 2, 3, 4 hours. Different type of malfunctions of the MRI machine occur at about the same frequency. Now, so they have the same likelihood. Now, part A, develop a probability distribution for the duration of a service call. If you assume x, or random variable, discrete random variable x, is the indication of how many hours it takes. So we're talking about 1, 2, 3, 4 possibility, and f of x is the discrete probability distribution. We are saying they are happening at the same rate, or so likelihood is the same. So it's 1 over 4, 1 over 4, 1 over 4, 1 over 4. So 0.25, 0.25, 0.25, and 0.25. So that is the situation, and that exactly matches if you're supposed to draw in part B, if you're supposed to draw a graph of the probability distribution f of x on the y-axis, and then x, or discrete random variable, on the x-axis, we can see that for the 4 possible value for x, 1, 2, 3, 4, since we are saying it's equally likelihood, therefore all of them equal to 0.25 on the y-axis for the f of x. So this is the right one, and of course and of course as a result you can see that this one is the incorrect one. So this one is incorrect, this one is incorrect, this one is incorrect. None of the other ones are properly representing this probability distribution. Now, part C, show that your probability distribution satisfies the conditions required for a discrete probability distribution. Two main conditions are here. One, the sum of, for all x values, the sum of f of x values should be equal to 1. And then for any x, f of x should be a value less than or equal 1 and greater than or equal 0. So these are the two conditions that need to be satisfied. Let's check them. Of course, one, you can see that the sum of values is equal to, so sum across all value of x, f of x, is equal to 0.25 plus 0.25 plus 0.25, and so on and so forth. And you can see the final answer for that is 1. So that is okay. So, and the second one, you can see that for all x values, f of x is satisfying what is mentioned here. So that is also satisfied. Therefore, yes, it does. And then what is for part D, it is asking what is the probability service call will take 2 hours. Well, it's easy. Take a look at, maybe the best way is visualizing it using the graph of probability distribution that we have. So it says, what is the probability a service call will take exactly 2 hours? By that, we are talking about x equal to 2, case of x equal to 2, which means this one, or which basically means in the tabulated version, this one. So f of x equal to 2 is equal to 0.25. So it's 0.25 or 25% chance. Now, let's talk about the last part here. So the last part, okay, so the last part, what is it saying? It says, hey, a service call has just come in, but the type of malfunction is unknown. So we don't know what type of malfunction we are dealing with. Now, with that in mind, it says it is 3 p.m. and service technicians usually get off at 5 p.m. What is the probability the service technician will have to work overtime to fix the machine today? Okay, so it means the service or the repair is starting at 3 p.m. And then it says normally the end of work for technician is 5 p.m. So if you're supposed to have a technician that is going overtime, it means the service time should go above 2 hours, passing 5 p.m., assuming it is started at 3 p.m. So basically what the question here is asking is, hey, find f of, let me put it this way, find the probability. Okay, so find the probability that the value of x is greater than 2, because it says we'll have to work overtime. To work overtime, it means we need to have a job that is taking more than 2 hours. So that means we're talking about adding, say, f of x equal to 3 plus f of x equal to 4. The only two other possibility indicating corresponding to a job taking 3 hours and 4 hours. Okay, so in that case, you would just add 0.25 plus 0.25, and then the answer is 0.5. So there is 50% chance or likelihood, or 0.5 probability that the technician ends up working overtime. I hope that this is helpful.